All right, so let's continue on in chapter 6.3, and this is day 3 of 6.3. Okay, so we'll take a look at more applications, and going over the first word problem, it says a ball is thrown with an initial velocity of 35 feet per second at an angle of 25 degrees with the horizontal, and we are asked to find the vertical and horizontal components. Okay, so, let me draw a picture of a vector that's roughly at 25 degrees. So there is my theta. We'll call it's 25 degrees. And you're asked to find the vertical and horizontal components. So the key on this problem right here is to see that the vector v, right, which stands for velocity, is 35. That's the magnitude. And on part A, they're asking for the vertical and horizontal components. So if you break it up, right, every vector has a vertical and a horizontal component. So right here, this guy right here is v of x, and we'll label this guy as v of y, right? And you can think of this, this vector v right here is the resultant, right? If I add vx plus vy, it will give me vector v, okay? So well, how do I find out what Vx is? Well, we know vector V in component form is Vx and Vy. And I had mentioned that the magnitude, right, times cosine theta will give you Vx, and the magnitude times sine theta will give you Vy. So if you forgot that, right, you can see that it's a right triangle over here, right? If I said cosine of 25 is adjacent over hypotenuse, Vx over 35. And if you get Vx by itself, right, it's just 35 cosine 25. And likewise, if you want to set up an equation for v of y, right, you could say sine of 25 is equal to opposite over hypotenuse. So v of y over 35. And if you get Vy by itself, it's 35 sine 25. Okay, so the vertical and horizontal components are given by this. V of x is 35 cosine 25, and V of y is 35 sine 25. Okay, so you could write it like this, or you can say, hey, V of x is just equal to this, and V of y is just equal to that. All right, so little review on horizontal and vertical components. The key concept is any vector, right, such as my vector v, can be written in terms of its horizontal and vertical components. And the equation, of course, is magnitude times cosine theta and magnitude times sine theta for your vertical component. All right, so for part B, they're asking you to find... it's a different problem here. Part B, the vertical and horizontal components are given at an angle theta with the positive x-axis, and they're 20 and 30 feet per second, respectively. So this one right here, they provide you the horizontal and vertical components. Okay, so v of x in this case is 30, and they tell you v of y is 30 feet. Sorry, v of y is 20 feet. Okay, so v of y is equal to 20. And what they want you to do this time, right, is to find the resultant, right? This would be the resultant. So in other words, what is the magnitude of v? So magnitude of v, right, is equal to the square root of 20 squared plus 30 squared. That's just using a Pythagorean theorem. You're going to get 400 plus 900, square root of 1300, which is 100 times 13, which is 10 root 13 feet per second. Okay, so there is the, there's my resultant, or my magnitude of v, just using Pythagorean. And then find the resultant vector's direction, right? What is theta? Of course, you can use a trig ratio to solve for that. Tan theta is 20 over 30. The direction is tan inverse of 20 over 30. And if you use a calculator, make sure in degree mode, 33.69 degrees. Okay, so problem number 1 is a review of writing component form. Any vector can be written in terms of its horizontal, vertical component. The horizontal is magnitude times cosine theta. The vertical component is magnitude times sine theta.